review of everything, and I've split it up into parts today. The first part is naming polynomials. There's a lot in it, a lot of different stuff, a lot of things. So you've got to stay on top of your work. You've got to stay on top of your lessons. If you miss a lesson, you've got to make sure you get that. You can't wait 3 weeks from now and decide to try to figure it out. So a polynomial is the sum or difference. So we add or subtract lots of different terms, monomials. The highest exponent is what we refer to as the degree. And your degree is what really shapes your graph. It's what determines how it's going to look. And it's important that we always write in standard, which means we write it with the exponents going largest to smallest. Now, assuming that it is in standard form with the highest exponent first, the number in the very, very front, that is what we call the leading coefficient. Alright, so the names of polynomials come from two different things. The first is the degree, and the second is how many terms that it has. So if the degree is 0, it's a constant. So this would be if we didn't have any x's at all. So it's just a number. If it has a degree of 1, it's linear. So this is just a plain x. 2 is quadratic. That's what we have spent a lot of time on. All x squareds. We didn't see any exponents bigger than 2. 3 is cubic. A degree of 4 is quartic. And a degree of 5 is quintic. Now the number of terms, if there's only one term, that's what we call a monomial. So it doesn't have anything added or subtracted to it. 2 terms is a binomial. 3 is a trinomial. And then from 4 up, we just get general and we say it's a polynomial with blank number of terms. And there probably are names for those, but we really stop at 3. So here on number 1, what is the degree? What's the highest exponent? 1. This, if you see an x, it has an imaginary exponent of 1. So my degree is 1, which makes it linear. And how many terms does it have? 2. There's a term, and there's a term. So binomial. Number 2, what is the highest exponent? 5, which makes it quintic. And how many terms does it have? 3. 1, 2, 3. So trinomial. Number 3, what's the degree? 0. There's no x at all. It has a degree of 0, which means that it is a constant. And how many terms? Just 1. Monomial. Number 4, what is the degree? The degree is 3, which means that it is cubic. And how many terms?
Polynomial, 4 terms.
Yep, there's 4 terms. So we would just say it's a cubic polynomial. You can abbreviate with 4 terms. Try numbers 5 through 8. All right, number 5 is a quadratic trinomial. Number 6 is a quartic monomial. And then 7 and 8, you could have a wide range of answers. But you definitely have to have x cubed and no exponent bigger than that. And it's got to have at least another term. And then a linear monomial could be some number with an x. And that's all. Any questions? Alright, so let's turn the page. And the next little bit of review that is going to be essential for you to know is exponent rules. And you should know most of these. You may not know them by name. But the product rule, if I have x to the a power times x to the b power. So I have 2 x's, I'm multiplying them. What do I do with the exponents? You add them. So this is x to the a plus b. So as an example, if I have x to the 5th times x cubed, that's going to be x to the 8th. The power rule, x to the a power raised to the b power. What do I do with those exponents? Multiply them. This would be x to the a times b. So if I have x to the 5th cubed, that would be x to the 15th. Good. The quotient rule, which means dividing. If I have x to the a power divided by x to the b. You can see that as a fraction or as just with division. We do what? Subtract. This would be a minus b. So x to the 5th divided by x cubed is x to the 2nd. Now here's some new ones that you may not be familiar with. If I have x to the negative a power, what we do is we take this x and you put it on the bottom of a fraction, and that a becomes positive. So this is the same thing as having 1 over x to the a power. And so if I have 3x to the negative 5th, what is exactly being raised to the negative 5th power? The x or the 3x? It's just the x. If I had parentheses around this, it would be the whole 3x. So the only thing that you move to the bottom is the one thing that has the exponent of negative 5. The 3 does not move. If there were parentheses around it, then they would both move down. But the 3 in this case is going to stay. The x to the 5th goes to the bottom. And in just a minute, I'm going to show you why this is the case, and same thing for this next one. So x to the 0 power. Does anybody know what that is? It's 1. And I'll show you why. So what if I had 3x to the 0 power like this? What would this be equal to? This part is 1. So it would be 3 times 1, which is 3. If I had parentheses around the whole 3x, then it would be equal to 1. But as of right now, only the x has the 0 power. Alright. So let's do some oh, no, I was going to show you. Okay. So I'm going to put up some problems, and I want you to get the answers. So on the side, I want you to fill in those 4 numbers. 3 to the 4th is equal to what? So it's 3 to the 4th, 3 cubed, 3 squared, 3 to the 1st. So as I am decreasing my exponent by 1, what's happening to these numbers on the side? I'm dividing by 3. And that pattern would continue and continue. So if I go down my list, my next one will be 3 to the 0 power. What's 3 divided by 3? 1, not 0. And then let's keep going. 3 to the negative 1st. What's 1 divided by 3? What's 1 divided by 3? 1/3. So you see how I have a fraction, and on the bottom, that was really 3 to the first. So if I have 3 to the negative second, if I do 1/3 divided by 3, I get 1/9. And 9 is really 3 squared.
So then would it just be like the next thing?
1 over 27. 1 over 81, yep. So that's why those are the cases. See, anytime you have the 0 power, it's going to equal 1. So now for some examples. Number 1, I have 5x squared times negative 7x to the 6th. These numbers out front are not exponents, so they don't follow these rules. You just multiply them like normal. So it would be, what's 5 times negative 7? Negative 35. And then I have x to the 8th. Here I'm multiplying two things, so you add the exponents. If you want to check your answer, 5x squared times negative 7, x to the 6th, doesn't really matter what number is stored. Then if I do negative 35, x to the 8th, I get the same thing. So I did it right. All right, number 2. Here I have 2x cubed y. All of that is squared. So any number in the front, you have to square it. So we have to do 2 squared. What is 2 squared? 4. And then I'm doing x cubed squared. That's x to the 6th. And then y, it's really y to the 1st, squared, is what? Y to the 2nd. Good. Number 3, we're dividing. Now here's the thing, when I see a fraction, I don't like to think of it in terms of the quotient rule, because that sometimes will result in some negative exponents, which then you have to take another step and move to the bottom of the fraction. So I like to think of it as canceling out. So first off, what's 54 divided by 3? 18. And then the x's. Think about if you had x to the 6th, which is really x times x times x times x times x times x over x squared. If we cancel out one from the top and one from the bottom, I'm left with 4 on the top. So I have x to the 4th on the top. So far, I don't have anything in a denominator. What about y to the 4th over y? Y to the 3rd, and would that be on the top or the bottom? If you cancel out, you have 4 y's in the numerator, a y in the denominator. They would be, the leftovers would be in the top. So y to the 4th. Oh, y cubed. If the 4 and the 1 had been switched, I would have had to make a fraction and put the y cubed on the bottom. Okay. Number 4, 10x to the negative 7th. What's that going to be? Yep. The x is the only thing that moves to the bottom and gets its turns positive. On that one, yep. If there were parentheses around the 10 and the x, then both the 10 and the x would go to the bottom. And one, yeah, we'd have to leave a 1 there. Number 5, I have the power rule and product. So you always want to kind of follow order of operations and do exponents first. So here we have x squared to the 4th power. What is that? X to the 8th times, what's negative 3 to the 4th power? No. Nope. Nope. Negative 3 to the 4th power. Nope. Nope. Positive 81. When you raise to the power, you've got to put parentheses around your negative 3. So this would be 81 x to the 4th. Good. And so now when I multiply, technically I have a 1 in the front. 1 times 81 is 81. X to the 12. Good. Number 6, we're going to distribute. So negative 5 times 2 is negative 10, and then I have x to the 7th. And then negative 5 times negative 7 is a plus 35, x to the 8th. Good. Questions? All right. Number 7, here I have 15 over 24. That does not divide evenly like number 3 did, but we can still simplify the fraction. So if you go to alpha y equals and type in 15 over 24, it simplifies to 5/8 because you can divide both of those by 3. Now let's look at the x's. If we cancel out, how many x's are left? 2 on the bottom. And the y's, if we cancel out, what's left? Y to the 5th on top. Okay. Does anybody need me to explain that further? All right, last one, I want you to try this one by yourself. So you should have first wrote down 25 x to the 4th y to the 14th times 6x cubed y. Because 5 squared, the numbers in the front, you do the normal operations. So the 5 is just being raised to the 2nd power. And this would be 150 x to the 7th y to the 15th. Any questions on that?